All right, this video is going to deal with how to complete the square to solve problems. So I'm going to start with some kind of basics, and we're going to work a little bit forward with that. Something like this, when we look at x squared equals 64, well, in our minds, we kind of know that's going to be 8. And then we have to realize that there also could be, so x equals 8 is our first answer that most people could, because 8 squared is 64. But remember, x could also be negative 8, because negative 8 squared also equals 8. And that leads us to something like this one over here on the right. X squared equals 7. We don't have a perfect square root of 7, but that doesn't mean there isn't a value for that. It's just an irrational number. And we're going to go back to a kind of a rule that we had. In order to get rid of the square root, what we want to do is take the square root of both sides. So x squared equals 7. What we do is take the square root of both sides of the equation. So we get x equals the square root of 7. But remember, just like over here where there's a possible of a positive or a negative, it's the same thing here. And what we write for that is a symbol that looks like this, plus or minus. So we put that in front of this. Now what this is a symbol that's used quite a bit for math people. And it really means that there's two possibilities. X equals the square root of 7 or negative square root of 7. There's two possibilities, one with a plus and one with a minus. And we call this plus or minus. Now the same method could be done over here on this side. It's just that 64, we know that's 8 times 8, but I could have done the same thing, square root and square root like that, and it becomes the same thing. Now we're going to use that principle to solve a problem like this. Now, to get rid of the square root symbol, I'm going to take the square root of both sides. So I take the square root of this side over here and the square root of this side over here. Remember, plus or minus. So a square root of a square just eliminates itself. So that's going to be x minus 4. And then the square root of 9 is 3. And that's plus or minus 3. There's two possibilities. So that becomes x minus 3, excuse me, x minus 4. X minus 4 equals 3, or x minus 4 could be negative 3. There's two possibilities there. And to solve this, I would add 4 to both sides. And I get x equals 7. And over here, I'm going to add 4 to both sides. I'm going to add 4, and I'm going to get x equals 1. And those are my two solutions. And I can check to see if they work. 7 minus 4 is 3. 3 squared is 9. That's good. 1 minus 4 is negative 3. Negative 3 squared is also 9. So that works. Now on the right side over here, we got a little bit of a different situation because the right side's not going to be a perfect square, but the principles are still the same. We're going to take the square root of both sides of the equation. And remember, it's plus or minus. So that's going to be x plus 3, because basically, if we remember the square root of the square, cancel each other out. And I don't know why I put 3. X plus 6. Let's do it in this. X plus 6 equals the square root of 3 plus or minus. And I'm going to write it twice like that. So the way we usually do that is now we're going to get rid of this 6. Instead of writing two separate equations like I did here, I'm going to get rid of the 6 first. So that's going to be minus 6 and minus 6. And we write x equals. Now these can't be combined because one of them is outside of a square root and one's inside. So we just write negative 6 plus or minus the square root of 3. And this is actually how we, in the math world, this is pretty much how we leave the answer. Now it is important that you understand what that means. So that would be x equals negative 6 plus the square root of 3, or x equals negative 6 minus the square root of 3. There are two solutions to that, and those are irrational numbers. Now, unless they ask you for a decimal approximation, you can pretty much leave your answer like that. If they did ask for a decimal approximation, we'd have to go to our calculator and put negative 6 plus the square root of 3, which is about 1.7. So that would be, we'd get some decimals for our answer. Okay, the problems are going to get a little more tricky. And this one here, here's the problem with this one. It's not set up, but I know when I get it, if I get it to look like this one here or this one here, where I have something squared equals a number, it's much easier. So I'm going to say, well, how can I do that? So my thinking process says, let's just rewrite this, x squared plus 10x, and I'm going to leave myself a space here, and then equals 11. I haven't done anything different other than just kind of move the equal sign over a little bit. Now what happens is I'm going to come up with a number that makes this whole left side of the equation a perfect square. And what I mean by a perfect square is when I factor it, I get something squared like this. Now, there's a couple of ways that we can look at it. Basically what happens is that any time you have a perfect square, let's just say I have x, I'm just going to make one up here, x plus 3 squared. If I were to do that, that would be x plus 3 times x plus 3, which when I did FOIL, I have x squared plus 3x plus another 3x plus 9, and that's going to be x squared plus 6x plus 9. And I want to look at the relationship between this number in the middle and this number here, and how it relates to this number up here in 3. Notice that with this number here, half of that number goes here, and that number squared goes here. So this is what we would call a perfect square, because we can factor it out to be a perfect square. So I have to figure out what number would I put here to be a perfect square. And the way we do that basically is we look at this number and take half of that and then square it. So half of 10 is 5. 5 squared is plus 25. So, but I've added 25 to this left side of the equation, which means to remain equal, I have to add 25 to this side of the equation. So now I would have, this can be factored, equals 36. Now I don't need to go through all the procedures of factoring where I say, I don't really have to do this and say x and x and numbers that multiply to 25 and add to 10. It's going to be 5 and 5. But I don't even need to do that because I know that I selected this number, so this would be a perfect square, and half of this number is what will always go here. So that's what I have. And now what I've done is taken a new problem and turned it into an old problem similar to that. So now I take the square root of both sides, and the square root here, plus or minus. So that becomes x plus 5 equals plus or minus, the square root of 36 is 6. Okay, I can subtract 5 from both sides. X equals negative 5 plus or minus 6, which means x equals negative 5 plus 6, which is 1, or x equals negative 5 minus 6, which is negative 11. And that's the answer there. Now, there are a couple of things we can look at there, and some of you hopefully are asking, well, wait a minute, why did we go through that weird procedure when if we're asked to solve this? Why didn't we just do this? Why didn't we just say x squared plus 10x equals 11 and subtract 11 from both sides, get everything equal to 0, because we did that earlier, plus 10x minus 11 equals 0, and then I can factor this, and I have x and x, numbers that multiply to 11 and subtract to 10. That's going to be 11 and 1. And the bigger number gets this sign, and then the other one gets a minus. So now I have two things multiplied to equal 0, so x plus 11 equals 0, x equals negative 11, or x minus 1 equals 0, x equals 1. Well, notice the answers are the same. And you can do it either way. In fact, if the numbers factor, this is a much quicker and more and a much easier way to do this. However, we do sometimes have problems like this, where it won't factor because there's no numbers that multiply to 2 and add or subtract to 6. So that's not going to work. So now we have to do completing the square. So that's going to be x squared plus 6x, and then we leave a space. and put equals 2. And I have to come up with a number that would go here to make it a perfect square. And remember, we take half of this number, which is 3. 3 squared is 9, so I put plus 9. And over here on the right, I have to also put plus 9. So that becomes x plus 3 squared equals 11. And I made it an easier problem now when I take the square root of both sides again. We're kind of doing the same procedure. The problems just get a little bit more complicated, where this becomes x plus 3 equals the square root of 11. And we can't do anything with the square root of 11. And remember, plus or minus. We can't do anything with the square root of 11. So what I'm going to do is subtract 3 from both sides. And that's going to leave me with x equals negative 3 plus or minus the square root of 11. And typically that is the way that we write that answer. So we'll just leave it like that. Okay, let's look at get it a little more complicated when I do something like this. Okay, I have numbers on both sides here. So what I'm going to have to do first, I want to have a different number than 3 here. Now there's different ways of doing it. Probably the easiest way is to subtract 3 from both sides. And I'm going to have x squared minus 12x, and I'll leave a space again, equals 2. And now, similar to the last problem, I look for half of negative 12, which is negative 6. Negative 6 squared is going to be plus 36, so I put plus 36 here, because that's negative 6 times negative 6 is positive 36. I have to put plus 36 over here. So the left side becomes x minus 6 squared, and that equals 2 plus 36 is 38. And it looks very similar now to the last problem that we had. It looks kind of quite similar to this one here, which looks quite similar to this one here. That we got them all to kind of look the same. I want them all to look something like this, where we have something squared. Let me erase this. It looks better if I do. We want it to look something like this. Something squared equals a number. So let's move on to finish this one here. I have to take the square root of both sides here. So I'm going to take the square root of the left side and the square root of the right side with a plus or minus in front of that. Remember, take the square root of both sides. You need a plus or minus. So x minus 6 equals plus or minus the square root of 38. There is no exact square root of 38, and 38 cannot be simplified at all because that's just 2 times 19, which are not going to be, nothing comes out of the square root. So I'm going to add 6 to both sides, and I'm going to have x equals 6 plus or minus the square root of 38. And that's the answer we're going to go with here. Remember, that means 6 plus square root of 38 or 6 minus square root of 38. All right, we're going to get a little more complicated with the next one, but the procedures are always going to work out to go back to the same thing. So I'm going to subtract 4 from both sides. And I got x squared plus 5x, and leave a space, equals 2. And this confuses people because now half of 5 is 2.5. Or we can write it, we can do it with decimals, or we can do it with fractions. I'm going to first do it with fractions. I'm going to say half of 5 is 5 over 2. Okay. Let me just, half of 5 is 5 over 2. So I have 5 over 2 squared. So 5 over 2 squared is going to be 25 over 4. So I write over here plus 25 over 4. And just leave it like that. Fractions are fine. Over here, I got to put plus 25 over 4 also. And now what happens here is this becomes x plus 5 over 2. Remember, half of this number goes right here, squared equals, and I have to go through my addition of fractions here. So a common denominator would be 4, so that would be 8 over 25 plus 25, 8 over 25, 8 over 4. Let's do that in a different color. I have 8 over 4 plus 25 over 4. Basically, what I did is I took the 2, and that's 2, 8 over 4, and 25 over 4. I just copied that down. That equals 33 over 4. So put equals 33 over 4. And now I'm going to go through the same process. The numbers just are a little different, but it's still the same process. We're going to take the square root of the left side and the square root of the right side, plus or minus. So I have x plus 5 over 2 equals plus or minus the square root of 33 over 4. Now I can do a couple of simplifications of 33 over square root of 33 over 4, because the square root of 33 over 4, oh, excuse me, that's not what it looks like. I wrote that one wrong. It's going to be the square root of 33 over 4 is the same thing as the square root of 33 over the square root of 4, which is the square root of 33 over 2, when I write it like that. So that's what I'm going to write here. So I'm going to put x plus 5 over 2 equals plus or minus the square root of 33 over 2, like that. Remember, the 4, basically a square root of each of those. Square root of 4 is down here, square root of 33 I can't do anything with. And now I'm going to subtract 5 over 2 from both sides. So I have x equals negative 5 over 2 plus or minus the square root of 33 over 2. And that's fine to write it like that, although often what we'll do is write it like this. We'll combine, since we have a common denominator, we'll say negative 5 plus the square root of 33 all over 2. And that's how we'd leave our answer. A little tricky. The next part's going to be add a little different twist to this, and that now we have a 2 in front of here. Now our whole principle of how we do this problem, the first thought a lot of people did was they said, well, 2x squared, we're going to subtract 4 from both sides. 2x squared plus 16x, leave a space, equals negative 4. Now, in order to do this, we cannot have this whole principle of half of this number squared only works if this number in front is 1, and it's not 1. So our method then would be to divide everything by 2. So I'm going to go ahead and divide this by 2, and divide this by 2, and divide this by 2. And it becomes x squared plus 16 divided by 2 is 8. X, and leave a space, equals negative 4 divided by 2 is negative 2. And we've made it an easier problem. Now we go through the steps we had before. The goal in math always is to take the new problems and turn them into old problems. This is an older problem that we did a few minutes ago. We're going to add half of this, half of 8 is 4. 4 squared is 16, so plus 16 here and plus 16 here. So that gives us parentheses, x plus 4 squared equals 14. And now we have back to what we started with. We have something squared equals a number. We go through the steps we always did. We take the square root of the left side and the square root of the right side with a plus or minus. And that gives us x plus 4 equals plus or minus the square root of 14. So now I'm going to subtract 4 from both sides. So x equals negative 4 plus or minus the square root of 14. And that would be our answer to this problem. Okay, the next one's going to be a little bit, we're going to add one more wrinkle to this. When I do this one, I look at this and I'm going to do the same thing I did before. I'm going to add 10 to both sides. So I have 4x squared minus 12x equals 10. And I got to figure out, remember, I can't do the fractions yet. I got to put a number here. I don't know what it's going to be, but I'm not going to do that yet. I'm going to first divide everything here by 4 because I need the coefficient of the x squared to be 1. So I'm going to divide each term by 4. And some of you may be saying, why didn't I do that up here? I could do it up here. It wouldn't matter. It would give me the same result. So this reduces to x squared. This becomes 3x. And then on the right, we have 10 over 4. I'm going to write that as 5 over 2 and leave it in fraction form. Now I got to figure out what number can I put here to make it a perfect square. And again, this is tricky because I have a fraction. So I'm going to have 3 over 2, or negative 3 over 2 squared, is because negative 3 over 2 is half of negative 3. So I have negative 3 over 2 times negative 3 over 2, which is positive 9 over 4. So I'm going to put plus 9 over 4. And on the right side, I also put plus 9 over 4. So now I'm going to simplify this this side here to be, well, this is going to come out to be x minus 3 over 2 squared. In the right side, I have to add these fractions together. Okay, that's going to be this first 5 over 2 with a common denominator of 4 becomes 10 over 4 plus 9 over 4, which is 19 over 4. And now I go through the steps I did earlier. I take the square root of both sides, so I'm just going to go through that same step now. Let's do this. Square root of this and the square root of this with a plus or minus. So I have x minus 3 over 2 equals plus or minus. Now remember, this can be written as the square root of 19 over the square root of 4, which is the square root of 19 over 2 with no square root on the bottom. So I'm going to write that as the square root of 19 over 2. And now I combine the 3 halves on the other side because I want to get the x by itself. So I do plus 3 over 2 plus 3 over 2. And this gives me, these cancel, and I get x equals 3 over 2 plus the square root of 19 over 2, which equals 3 plus the square root of 19 all over 2. And that's going to be the answer to that one. At this point, we're just going to stop and kind of, I suggest maybe you go through the problems, watch it, go through the video, and I would suggest possibly going back over them again and maybe trying to do the problems without the answers written below and see if you get the same thing. All right, hope that helps. Sorry this was kind of long, but it's a lot of material to get in. Okay, thanks.